factor affecting on viscosity of liquid. The viscosity of the liquid affected by several factors. The first factor is temperature. You know that the coefficient of viscosity of gases is increases with increase in temperature. In case of a gas I am talking. But in case of a liquid, it is inversely proportional to temperature. Why? Because you know that the viscosity coefficient it is directly proportional to intermolecular force of attraction. If the intermolecular force of attraction is more, the viscosity is more. But the fact that temperature and interparticle attraction, these are the two inverse phenomena. That means if the temperature is increases, the force of attraction between the molecules reduces. If the force of attraction between the molecules reduces, so the viscosity is decreases. That means they do not able to cause retarding force. The tangential force which is acting upon the flow of the liquid, it is decreases. So that's why temperature it is inversely proportional to viscosity, because if the temperature increases, the force of attraction between the molecules decreases. But in case of a gas it is different. In case of a gas, if the temperature increases, the gaseous molecule get kinetic energy. As a result, the collision is more. If the number of collision frequency increases, if the collision number increases, so automatically the resistance will be more and viscosity is increases. In this case, so at low temperature, so viscosity is more compared to, because at low temperature what happens, gaseous molecule comes closer and liquefaction takes place. And when we come to liquid state, the force of attraction, a new force which arises between the gaseous molecule. So as a result, the viscosity increases in case of a gas. So once again, dear students, so the temperature in case of a gas is different. In case the effect of temperature in case of a liquid is different. In case of liquid, the temperature is inversely proportional. That is, temperature increases, viscosity decreases. But in case of a gas, temperature it is directly temperature. If temperature is less, viscosity is more. So this is the inverse factor in case of a gas. Next important factor is size of a molecule. If the molecular size is more, so mass is more, so what happens? So they are slowly moving, and as a result, the particle size is more, the van der Waals force increases, and another side they are slowly moving. As a result, viscosity is increases. Another important factor is intermolecular forces. Yes, it is the main factor driving force for the viscosity. Greater the intermolecular forces, greater will be the viscosity. That's why we found that the more viscous liquids are sticky nature. They possess little bit of gummy nature, adhesive in nature. So these are the factor. Let us solve some numerical problem. So first problem, please write down the problem. Water requires 120.5 seconds to flow through a viscometer, and the same volume of acetone requires 49.5 seconds. The density of water and acetone are 9.982 into 10 to the power of 2 kg per meter cube and 7.92 into 10 to the power of 2 kg per meter cube at 293 Kelvin respectively. Viscosity of water at 293 Kelvin is 10.05 Pascal per second. Calculate the viscosity of acetone. Dear student, if you really understood this problem, you can easily understand Bose-World viscometer experiment. Okay, in this problem, they are given two liquids. One is water and another one is acetone. Before going to solve the problem, dear students, so write what he has given and what we have to identify. In this equation, he has given time. So water takes 120.5 seconds and acetone take 49. You write the given. So this is the formula which we used. Okay, you write time of both the liquids and write the density. The density of water is 9.982 10 to the power of 2 kg per meter cube. You remember the SI unit. During solving the problem, you have to write the given and you have to convert all the given into a single system of SI unit. Either they are in the MK system or in the CJ system. Here it is in the MK system, that is meter and kg second. So that's why you keep that system. So write the given, write the time and write the density. So this is liquid number 2 and this is liquid number 1. The liquid in which you are going to identify the viscosity coefficient, you take it as 1, and the reference liquid you take it as 2. So this is T2, then T2 is equal to 120.5 and T1 is 49.5 seconds, and the density of water is 9.982 and that of acetone is 7.92 in 10 to the power of 2 kg per meter cube, and the viscosity of water eta 2 is equal to 10.05 Pascal second. You know the SI unit of 10.05 Pascal second. So note down all the given things, and the only thing is we have to identify N1, that is viscosity coefficient of acetone. So dear student, the problem is very simple. In this problem, he has given the data for two liquids. One is for water and acetone. Here clearly mentioned the time taken by both the liquids, the density of both the liquids, and viscosity coefficient of water. So 5 known things are present. Only viscosity of acetone is unknown. Then the formula which is used to solve this problem is eta 1 is equal to d1 t1 divided by d2 t2 into eta 2. So this is the numerical, this is the formula. You write the formula. So in this formula we know the value of d1 t1 d2 t2 into eta 2. Substitute the value in this equation. Then after substituting and simplify, so you are going to get the value. So the value of eta 2 is 3.276 Pascal second. So you solve it. Then the next problem, the viscosity of acetone is 3.276 Pascal second. Then second problem. So dear student, while reading the problem itself, you please note down the given data. The coefficient of viscosity of two liquids at 298 Kelvin are 1.48 into 10 to the power of minus 3 kg per meter per second and 1.594 in 10 to the power of minus 3 kg per meter per second. Here instead of given the SI unit in terms of Pascal second, so he has given in terms of kg per meter per second, both are same. Because if we know that 1 kg per meter per second is equal to Pascal second, and their density at the same temperature are 8.07 in 10 power minus 10 power 2 kg per meter cube and 10.17 in 10 to the power of 2 kg per meter cube respectively. So you take liquid 1 and liquid 2 and you goes on writing the data. So T1, so T2 and D1, D2 density of liquid 1 and liquid 2 and viscosity coefficient of 1 and viscosity coefficient liquid 2. So he goes on writing the data. So here he has given viscosity coefficient of both the liquid. So these two terms are already given, and he also given the density. So D1, D2 is given, and see if the time of flow for first liquid is 100 seconds, calculate the time of flow for the second liquid. Yes, here you have to calculate the time taken by the second liquid by using first liquid. So here the time of first liquid he has given, that is 100 seconds. So then you have to calculate the value of T2. Here T2 is unknown, dear students. In the previous problem, we are calculated eta 1, that is viscosity coefficient of liquid 1. But here he already given all the things. So except time, then you know the relation, that is n1 divided by, so not n1, eta 1 divided by eta 2 is equal to d1 t1 divided by d2 t2. So here what we want is, we want t1, because here, sorry, t2, we want t2 is unknown here. Take t2 to the LHS, then send the remaining term to RHS, then t2 is equal to what? Then t2 is equal to d1 t1 divided by d2 into eta 1 into eta 2. Substitute the value in this equation. So this is the equation for T2. Substitute the value. If you substitute the value and after simplification, you are going to get 89.9 seconds. This is the time taken by the liquid to flow from the reference point A to B. So dear student, if you really understood these two problems, you can solve other problems. So next class I am going to start surface tension.